Welcome to Benchtalk 2024. It is incredible to have you here. This is our biggest Benchtalk ever. Almost 700 of you signed up. Believe it or not, the very first Benchtalk was small enough that it fit into the bar at Cafe Art Science, RIP, over in Cambridge. We've come a long way since then. And I want to thank you for joining us today. We've got a great program for you, and it's a full house of leaders from science, machine learning, and IT. If you don't know me, I'm Saji. I'm one of the co-founders of Benchling. We've been working on Benchling since 2012. Our original vision was simple. We started Benchling to build modern software for modern science. There's just too much toil in science, and we want to help. Great software can and should save you time. Today, we're privileged to power R&D for more than 1,300 of the brightest organizations in the world. And whether you're 5 scientists working on the next great molecule or 2,000 scientists around the world pushing the frontiers of scale, we want to thank you for your trust and partnership. I feel really lucky to be part of this industry. No doubt the last 2 years have been a really tough time in biotech given the economic climate. But if I zoom out and look at the last 10 years, the arc of progress has just been absolutely spectacular. I have a lot of physician friends, and many of them started their training around the time that we were getting Benchling off the ground. I love asking them if cure was in the vocabulary when they were studying all these horrible illnesses that many of you are working on solving today. And the answer is no way. And here we are today talking about just that. At the same time, software is going through its own tectonic shift. The last time this happened was in 2007 when the iPhone was launched. Computational capabilities are absolutely exploding right now, and biology is a massive beneficiary of that. When my co-founder Ashwin and I started Benchling, we weren't dreaming about AI, being totally honest. Back then, I would have settled for killing the paper lab notebook. Looking back, Benchling was very much a bet on the vector of compute and data becoming more important. And I think we got the direction right, but the order of last year has opened my eyes to how much bigger the order of magnitude is than we could have ever expected. And all of a sudden, it's become this moment that we didn't know we were waiting for. Bio and compute have finally converged. It happened gradually and then suddenly. Bioinformatics has been around for decades. The biotech companies were some of the earliest adopters of machine learning in the 80s and 90s before it was cool. Scientists, I think, for the last decade have really been learning to code, and ML researchers have been learning biology. But this AI shift has truly cemented it. The last year has given us so many bio-AI tools that are going to generate an order of magnitude more high-quality ideas for therapeutics and other biological products. And massive progress in LLMs is going to help automate so many parts of R&D that would otherwise be this incredible bottleneck to test and develop all of these ideas. It really is the beginning. Our 2024 State of Tech in Biopharma benchmark showed that about 19% of you feel like you've adopted AI and ML sort of across your entire organization. And let's be real, most of that is probably using ChatGPT to respond to annoying emails. But we are here to make sure that software finally catches up with science. But it's going to take radical change in R&D itself. The way R&D works today has been largely centered around the wet lab. And the wet lab is here to stay. Science is always going to require real-life experimental data. Applying AI requires changing R&D and reinventing it, though, to unite the wet lab with a second, equally important lab, the dry lab. Collaboration between the wet and dry lab should be effortless. Yet everywhere I look, it's extremely difficult. And for good reason. Very few industries have to bring together bits and atoms, elegant computer science abstractions with messy biological realities, vast multidimensional data sets with singular cells, the way that biotech has to do it. But we believe in a future of wet and dry lab connectivity, which will bring together the compute, the data, and the analytical capabilities that scientists need at every step of R&D. And so we're investing in 3 areas to make this happen. The first is software to scale wet lab throughput massively. It's the only way to keep up with the sheer volume of ideas that are coming out of the dry lab. Modern software can connect experiment design, data capture, and data analysis. And the result is a much more automated end-to-end workflow for wet lab scientists. So despite what's written about in the news, AI is not coming for your job, but it is going to give you superpowers. And I think LLMs thoughtfully applied are going to give you back so much time for doing actual science. The second area is software to power the dry lab. High-quality structured data from the wet lab is fuel for computational science. We're building the pipes between the wet and the dry lab. But these pipes are a lot more than just generic ETL. They need a molecule-aware data model that's going to save the dry lab what today is a ton of time wasted cleaning and preparing data. And going a step further, those pipes can also provide a lot of the out-of-the-box scientific and analytic capabilities to offload basic dry lab workflows and free your machine learning researchers up to work on truly novel work that's going to drive their science forward. To make both of those two halves work, we're going to keep investing in our open platform. As insane as it sounds, when Benchling launched, we were the first product of our kind that had an openly published API. But that should be table stakes. There's way too much time spent rebuilding the same integrations at every single company. And in practice, the effort required to do that is so high that scientists end up being the manual human APIs shuffling data around themselves. It's time that biotech had a true ecosystem of reusable integrations to reduce the time that everyone has to spend reinventing the wheel, and we're going to lead the charge here. I'm so excited for what we can do for your R&D. Bio and compute coming together has opened so many possibilities, and these investments are only the first step. So now I'm going to welcome our Chief Product Officer, Shauna Wolverton, to the stage to show you how we're making each of these a reality in Benchling for you today.
Thank you, Saji. Hi, everyone. I'm Shauna Wolverton. I'm the Chief Product Officer here at Benchling. And I like to talk about the future as a product person, but I thought it'd be fun if we go back 10 years, do a little time travel. The world was a little different. Pharrell's happy? Inescapable. We could not escape it. It was everywhere. Everyone outside the room was finally learning about ALS through the Ice Bucket Challenge. This was fun, a little cold. And this is what notebooks look like. Something had to change. And so that was the year we launched the Benchling notebook. And since then, we've defined what it means to be a modern notebook. It's cloud native, it's built for scientists with an easy, intuitive UI, and it connects to the molecular biology tools you're used to. And today, Benchling Notebook is the home of scientific productivity, but we're not done. We were with you 10 years ago as we moved into the era of biotechnology, and we're going to continue to be your partner as we move into the data-fueled computational era. Because after all, your scientific data is the lifeblood of R&D. And as excited as we all are about this data-fueled future, all of that data still comes from the good old traditional wet lab. And today, scientists are struggling to manage it all, from capturing to analyzing and everything in between. And good old cut and paste, it's just not gonna cut it anymore. So, if you were with us last year, you might remember we introduced Benchling Connect. We really solved the first part of this problem, automating data capture. And we have been busy ever since. We now have over 120 connectors to instruments and software that you rely on. And we're constantly adding more. But what about the rest of the equation? Going from data to insight. Capturing data in the lab is obviously invaluable to your organization. But the scientists doing that work, well, they didn't always see that value. Oftentimes, their ELN is a place they had to go. And we wanted to change that. Now, it can be a place they want to go, with tools built in for analyzing data and reaching new insights. And that's why I'm super excited to tell you all about Benchling Analysis. We wanted to make it dead simple to query your data in Benchling, no SQL required. Collate and transform that data, produce finished analysis, whether that's charts or tables, and it had to be automated so that those people could do the work at the throughput demanded of them. Now you can go from experiment to analysis in seconds. Eliminate error-prone, difficult to trace, copy and paste steps. And finally, maybe if you're lucky, you can finally do away with those VBA macros that are doing all this work for you, all without writing a single line of code. So with that, I'm going to bring up Nick, and we're going to check it out live for a little demo. Welcome, Nick.
Hey, Shauna, how's it going?
I'm going to give you this.
Oh, thank you. Thanks for having me.
Of course. What are you going to show us today, Nick?
So we're going to do some real science with y'all on stage today. But before we jump into that, quick show of hands, how many of you run a quantitative ELISA in your lab today? Yeah? Good amount of us. Awesome. So that's what we're going to do on stage. We have a SpectrumX plate reader with us, and we're going to automate a quantitative ELISA analysis with just 3 clicks without leaving the notebook. And Shauna, are you still up for maybe helping us?
Do I get to reprise my role?
Yes.
As lab scientist?
As our bench scientist.
Some might remember. Put my lab coat on, get into character. Very good.
Awesome. So Shauna's going to help us prep our plate and run it through this SpectrumX. And while she's doing that, I'm just going to give you guys a little bit of context. We have Benchling analysis open here. And if you're running a quantitative ELISA, you're likely ultimately looking for analysis that looks something like this, where you've calculated your standard curve, and then you need to interpolate the results onto your unknown samples so you can come up with a concentration prediction. And then you likely want to visualize it so you can compare the sample results, filter out those that were below your range and quality control criteria or above range. But to actually produce this analysis, it's a pretty complicated process of grabbing your raw data. You need to use an Excel or VBA macro to cleanse it and prep it so it's analysis ready. Visualize that in a plate heat map so you can see your measurements. Run a 4PL or linear regression so you can plot your controls. Interpolate the results so you can come up with your concentration predictions. And then ultimately, that's your spot to end up visualizing the results so you can actually share this with other colleagues as part of your analysis.
Nick, I know a lot of this is about saving scientists time. I've heard this is pretty fast. You're going to show them. I've loaded the plate. I go get coffee?
Yeah,
Show them
you
how it works? Perfect. I'll be right back.
No data wrangling. Go get coffee. We'll run the analysis and get back to you. All right, so all of this has been pre-set up in what's called an analysis template inside Benchling. And you can kind of think of an analysis template as a pipeline where you feed your raw data into it. It then runs all of the processing steps, creates your computed columns, runs your regression, and then creates all the visualizations automatically and repeatedly so you can standardize the types of analysis you're running. So to actually execute this in the lab, back to sort of the 3 clicks that we're going to use to automate the analysis, we have a notebook entry set up for this quantitative ELISA. In that, we have a run set up, and that run has a connection established to the SpectrumX plate reader. So while the plate is running, the connection is very important because it's what lets Benchling talk to the instrument that's local in the lab. So when data files become available, it just automatically syncs it to Benchling without Shauna having to do anything, right? So now that that's been running for 15 or so seconds, we can hit, this is where the 3 clicks come in play. We can hit retrieve data, that's our first click. And there's our file, automatically synced from the plate reader. We're just going to select the most recent one. You get a quick preview so you can do some quality control and just make sure the data looks okay. It's our second click. And then our third is process. Now what's happening behind the scenes is that raw file is being converted by Connect into an analysis-ready data set. It's also kicking off that analysis template that we showed you. And let's see if we can catch this in the act. Right, so that pipeline is now running. You can see the little spinny wheels on the pipeline as the data is moving through the calculated columns that are created, all of the views, our regression, and ultimately it is producing our end visualizations that are required for this analysis. And it looks like that just finished, and now we have our visualizations automatically run as part of the analysis. Not only that, but because this analysis template was configured to embed the end results back inside the notebook entry, automatically those charts were embedded back in the notebook without a scientist ever having to leave this place. So really just trying to make sure that we can keep our scientists in the place where they do their work, automate analyses with just 3 clicks.
And give them plenty of time to get coffee.
Yeah, that's
Awesome. Nick, this was great.
Thanks so much, Sean.
Thanks so much. Perfect. Thank you. That's amazing. Thanks, Nick. I'm super excited about this. Available now, dataset creation, data transformation, all the charting and visualization and connection back into the notebook. In a limited release is some of that great stuff you saw around the automation templates and regression and interpolation. And we're really busy still working on no-code dashboarding, hypothesis testing, and some natural language query tools. So lots to come here. We're really, really excited. And we know that analysis is only one piece of the puzzle here. So we're doing even more to really help scientists scale the lab. We launched recently an entirely new experience for working with plates in Benchling that help you visually design and annotate wells in an interactive wizard. Super awesome. We also launched BLAST alignments to help you quickly and securely annotate your sequences. So you can learn more about these and more in our bioresearch deep dive session, which is right after this one at 10:15 today. Hope to see you there. A lot of what we talked about today is about scientist productivity, but we're not done. There's so much hype around AI. We've all heard it, and so much of it is about the super cool models around prediction and functional and shape. It's all awesome. It's great, but we think there's actually some lower hanging fruit that we should go and attack to really drive productivity in the lab. So much of a scientist's time is not spent doing science. They're documenting, they're reporting, they're reviewing. And to scale, we must free them from this toil. We believe that AI, in particular LLMs, have a critical role to play here. But we also know we can't just build generic chatbots. We need to be thoughtful about the specific place in a scientist's workflow where LLMs can really have an impact. Last year, we talked about this vision, and I'm excited to show you real features that are now in customers' hands. So we're going to go through 2 common things that take up a scientist's time and how LLMs can help capture, we're going to show you capturing data and reviewing data. Who amongst us has not received a file, maybe from a partner, maybe from a different department, with all of your sweet, sweet data locked in a PDF? Today, there's really 3 things you can do about it. You can go ahead and attach the file, you've got it there, it's a record, but it's not particularly useful. You can manually transcribe the report into structured tables, cutting and pasting, because I know whenever I cut and paste from PDFs, works awesome all the time. You can hire a whole team of interns. It's really best to show those budding scientists the joy of a career in science very early. It's good. But you did studies months ago. You've received tons of reports, and you still don't have answers. And no amount of Mountain Dew is going to make those interns type faster. So we really thought this was a great place for Gen AI to help. So let's take a look. Let's say you get a file from a CRO you're working with. It looks like this. It has clinical chemistry data about each animal you're working with. It's sort of structured, but there's still a lot of data munging to do to get this into the right shape. But beyond just transposing it and grouping it together, there's a big problem with the animal IDs. The CRO renamed them. Why? Why did they do that? But they did. And you call and ask and say, hey, can you send us a new one? And they say, sure, 3 more weeks. So there's still more to do. But then you notice there is a flexible fill button in Benchling. So you grab the file, bring it into Benchling, and magically, the data gets filled out for you. No interns were injured in the making of this demo. But wait, there's more. Did you see, actually, this is really cool. The LLM actually also fixed the ID naming. They have, the LLM has access to the data you registered in your notebook entry and can automatically make that connection for you. It can also without any special prompting or anything, understand how to fill out drop-downs and name fields that don't match. So we're really excited about this, and it's in the hands of customers today. Customers like Verve, thank you, I know you're here today, they're already talking about how much time it can save, but how it really helps centralize structured data by making the easy thing to do also the right thing to do. How often do you get that? It's amazing. All right. The next demo I'm going to show you is about notebook checking. Who doesn't love reviewing notebook entries? It's so much fun. And there's a whole bunch of mistakes that can happen in entries. Like here we have someone forgot to check off a step. They forgot to add one of their containers. Some of them are simple typos. Some of them are more consequential, like maybe we forgot a decimal point. That has consequences. So we wanted to help the reviewers catch these things, but we know that they can't always catch everything. So we have a whole bunch of tools in the schema that help prevent some of these mistakes. Who has not written a conclusion like that? No one in this room would. Nah, you wouldn't. But that's the kind of thing that the notebook checker can do, right? We have out-of-the-box rules for checking, and then with just simple natural language, you're able to set your own rules so that you don't have to go back and forth and review and reject and wait for someone to come back from vacation to get through all of your notebook checks. So this is also available today. You can see here some of the rules that can be applied, and so much toil reduced here. So that's notebook check. Again, with our apologies to everyone in the room whose very favorite activity is reviewing. The best part of work, isn't it? So what's next for Benchling Intelligence? Today in beta, we have the notebook check and guided search coming soon, the flexible data entry you saw earlier, some interesting things around data analysis, and Insights SQL Assistant. And we have a workshop tomorrow at 1:30, so if you can, we'd love to have you there. But data isn't the only challenge. You all use a lot of software. And let's talk about how we're building Benchling to fit right into that portfolio as a powerful open platform. And we're going to go back in time. Once again, it's fun. 10 years ago, enterprise software was mostly installed on premise with database connectors, data warehouses, data mart. There's a lot of data marts. Applications couldn't really be configured. You had to write a lot of custom code and customize that stuff. Your integrations were all custom, brittle, expensive, and needed to be rebuilt again and again. And data was impossible to access, siloed, and effectively lost. Today, the industry needs platforms that are open. We owe it to the work to be more agile, to stop fitting new workflows into old paradigms. And we owe it to the business to be more efficient, easier to implement and integrate, and let's be honest, tear out if we're not earning our keep. Here's what we believe an open platform means. It's extensible, interoperable, and accessible. And I'm going to hand things to Remus to talk through what that means at Benchling. Thank you. Remus, welcome.
Thanks, Shauna. Appreciate it. Hey, everyone. I'm Remus. I run product for platform and infrastructure here at Benchling. Developers and IT teams play a critical role in organizations because they're driving the creation and maintenance of software, which is central to the way science happens in your organizations. We here at Benchling are committed to those phenomenal developers and IT teams across the industry. So let's start with extensible. And if you know me, I love the dictionary and I love definitions, so we're going to get into it. Extensible, able to cover a large area. And platforms are extensible if they're able to do that. Platforms provide a set of primitives and tools that allow all of you to customize the product experience beyond the core product capabilities. Now, how many of you found yourself in this situation where, frankly, requirements will change, or you're trying to roll out a process and something might have to change associated with that? In the fullness of time, things will change. But the real question you should be asking yourself in those scenarios is my software going to change with me? Extensible platforms evolve with your business needs because they provide those building blocks and hooks so that you can mix and match all day long. And that ability to mix and match is what creates cost efficiencies because less time is spent actually writing custom software and instead bringing new functionality to where your people are actually doing all of their work day in and day out. And a great example of Benchling, or extending Benchling that is the integration Merck has built with the Azenta BioStore. The BioStore is this gigantic room-sized automated freezer. Integrating with the automated freezer can be a very difficult challenge. Yes, it's difficult technically. Yes, difficult. But the user experience is also very key. When you think about that and compare it to storing, let's say, a sample in a bench freezer, storing a sample in a bench freezer can actually be pretty easy. So how do you bridge the gap between the two to make what is easy, simple on the other side? With the extensibility of our platform, and in this case, Benchling workflows, and our app framework model, Merck was able to do just that. Scientists see the immediate feedback on their actions that they're taking, and complex business logic can be automated for them so that they can focus on getting their experiments done and pushing the science forward. The Merck team is actually in the audience today, and I highly recommend you seek them out and learn more. But that's just one example of all the cool things y'all have built on the Benchling platform. This is just a sampling of some of the things that we've seen where some folks have built custom logic for validation input to controlling robots and a notebook entry. I mean, that's pretty cool. And this is just, again, a sampling of all the cool things that we've seen you build on top of this platform. But today, extensibility can take many different facets. And what I'm most excited to announce today is an enhanced Benchling app canvas. You now have the ability to create what feels like native Benchling UI experiences that can be customized for your use case. If you can dream it, the app canvas will allow you and your developers to actually create that experience inside of Benchling. Starting today, you can embed an app canvas anywhere in the Benchling notebook, and over time, we want to give you this ability to embed app canvas anywhere inside of Benchling. Again, if you can dream it, we want to make it possible. All right, now let's get into the second definition, interoperable. Again, back to the dictionary. And for platforms, what does this mean to be interoperable? It means that data needs to be able to be exchanged from one system to another. And frankly, interoperability has reached a crisis point in the labs. I mean, crisis. Now, we ran a survey earlier this year and found scientists use more than 5 separate software applications to get their job done. And that burden is 2x bigger in larger organizations. That's a shit ton of software, I'll tell you. But what gets worse when these pieces of software aren't interoperable, no standards are being followed, custom integrations are required, and if no integration exists, again, it's that issue of copying, pasting data all over the place. Just not great. So again, let's just zoom out to further the point. This is the software landscape for R&D. I didn't even put everything on this slide, and frankly, if I did, that's just way too much friggin' software. So just take that for what it is. I mean, when you look at all these categories of systems and tools, again, it's just a fraction of what's out there. Can you imagine as a developer trying to create integrations between all of these systems? Worse yet, maintaining all that software. I mean, is software really free? An interoperable platform will go beyond to reduce the friction between all of these systems and make integration seamless. So today we're excited to announce shareable apps. And the first benefit of shareable apps is that you actually get to write one copy of your software and share that across many tenants within your organization. That's super exciting. Or for the case of you integrators or third parties here in the room, you get to write one piece of software and that can extend across many different Benchling customers. It's super exciting. You'll get all the benefits of our platform between our data storage, data modeling, permissions, so that you don't have to build those things yourself. Now, the second benefit of shareable apps is actually our app config. And imagine being able to write that one integration, and for anyone that wants to use it, they can tailor it through configuration for their needs, which means you don't need to build multiple versions of the application. Somebody can come in, configure it for whatever their use case is, and again, you don't have to write that custom software. Now, this app config is one way that it reduces the brittleness in terms of ecosystem integrations, and it's super exciting. Shareable apps are this foundation of an open, interoperable ecosystem. Integrations can be created once and deployed industry-wide. Now, I want to walk through an example. A common integration we see amongst our customers is the need to maintain some source of truth outside of Benchling, but be referenced within the Benchling UX itself. The platform makes it easy to keep these external systems of record in sync with Benchling, and I want to show you how with Cluster Market. Cluster Market is a system of record for equipment that unifies asset inventory, scheduling and bookings, training statuses, and a whole host of other things. And all of this is in service of accelerating your team's research efficiency. With the Cluster Market app, users can now reference equipment maintained in Cluster Market directly from within Benchling, for example, a notebook entry. This integration just takes minutes to set up and ensures consistency in data, as well as making the scientists live much easier. So the Cluster Market team has provided us a demo today. They're here in the audience. Go say hi. So what you're going to see us do here is that we have this cell incubator. We're going to create this piece of equipment inside of Cluster Market itself. Okay, equipment created. And we automatically move over to Benchling, and you can see that I can reference this piece of equipment almost immediately. And I can take this piece of equipment and look it up in various tables, and you can see how all of the data gets populated almost immediately inside Benchling itself. I can go in, look at some extra details about that piece of equipment, and follow a link over to Cluster Market itself to go schedule use of this piece of equipment. It's super exciting. And I can schedule it for myself, and I'm off to the races, and I've just created the seamless experience between the two products. And that's the benefit of integrations with Benchling. So the Cluster Market team used the full power of the Benchling developer platform to build a secure, scalable, and out-of-the-box integration. For the developers and IT teams in the audience, with Benchling apps, you can now create integrations in minutes instead of months or years and build your own shareable apps that work for you and other organizations. Now, Cluster Market's a great example of an out-of-the-box integration that uses shareable apps, but we've been working hard over the years to build out this ecosystem, and we're so proud of the developers that have been building reusable integrations. Along with Cluster Market, there's 8 other companies here at Benchtalk that do this kind of integration. Go seek them out, learn about what they're building, from inventory to automation to computational notebooks. Just see how it is, how easy it is to integrate with Benchling. Lastly, let's talk about accessibility. Now, if you weren't sick of my definitions yet, I've got one with 2 parts: able to be reached and easily understood. Now let's go do the back in time thing once more. If you think about legacy software, documentation was either opaque or didn't exist. Error messages gave you no information as to what was actually happening. How many times have you been given something that just says system error? Like, what the hell are you supposed to do with that? I don't know. And finally, worse yet, the inability to get the data that's housed in those systems out and use it for whatever means necessary. To make a platform and the associated data accessible, you need more than just an API, like we've talked about before. Benchling was one of the first to have that API. You need one with high coverage and high consistency. And that's what we're building with our V3 API. In a complex environment, data needs to flow between systems. We covered that in the interoperability section. But if we give you unfettered access to the underlying platform primitives themselves, you have the power to access the data in a way that matters for you. This is especially true in today's world, where data is the lifeblood of AI and ML. The V3 API will give you that power to get the data out in any way, shape, or form that you need with that high coverage and high consistency. Now, I want to go through an example, and I'm sure for the developers in the room, you probably could pick out the differences pretty quickly, but otherwise you might look at this and go, this is probably the same thing. I do want to point out in the V3 API, you will see in the path here that I've highlighted at the bottom that what we've done with this is that we've provided actual semantic meaning within the APIs themselves, which means as you build data models within Benchling itself, that will then get exposed as endpoints for your APIs so that you understand what you're actually working with when you go to hit these APIs versus, I don't know if you can tell what's at the top, because I frankly can't. But it's small changes like this that have profound impacts on developer experience, and that's why we're releasing APIs like this. This API v3 really matters. But it's just more than doing so on the API. It's about being able to tell you what is actually going on, and the API documentation is also very important. So I talked about the data model actually being tuned to your organization, your tenant, your science. The API v3 documentation will do the same thing. As you go through it, you will see all those endpoints documented for you and your organization so that you know exactly what to work with. So the v3 API is right now available in a closed beta along with the developer documentation. We have a handful of you in the room here that are testing this out for us right now, and we really, really appreciate that feedback. Coming soon, we'll open this up to more and more of you so that you'll get access to this and be able to play around with it. And we're looking to explore new APIs under this v3 umbrella. The first one is the Events API. Imagine that same coverage and consistency in a way that allows you to know when every single data change happened and when user actions were taken so that you can actually respond to those things as a developer with your software almost immediately. And the next one is the Bulk API. Now, I talked about APIs being able to move data in and out, but what about this use case where you need to take everything that's in Benchling and move it out into some data lake somewhere else? That's the other piece that we're working on and looking for more feedback on. So come check out our developer session later today at 11:15, and you'll get some more information on all of that. In summary, open platforms have to be extensible, interoperable, and accessible. These are the facets that build trust between platforms and the developers that use them. Take my word for it, I've worked with developers my entire career. Developers can see through the fluff that anyone's putting out, and I will tell you that we're committed to you, the IT teams, and the developers. And if you don't want to take my word for it, ask developers here in the room, and they'll tell you what the truth is. A truly open platform will allow you and the developers to create an engaging system and processes that will accelerate your R&D now into the future. Speaking of the future, I want to introduce Ashu to the stage, president and co-founder of Benchling, to talk about the dry lab and the role of modern software. Ashu.
Thank you, Remus, although I will not call you the past, I guess. In all kind of seriousness, a truly open platform has been a critical part of the Benchling strategy since day one. And it's just really great to see how Remus and the team have kind of driven that forward through both basic kind of shareable apps and then also the new API v3. So, an open platform is really the foundation underneath the third and final role modern software needs to play, which is powering the actual dry lab. This role is becoming more and more important as computational science becomes a really key piece of every stage within R&D. AI for the actual biotech space is getting so much faster, and so many bio-AI tools have launched even in the last few years. It's so basically exciting to see AI basically coming out, not just for antibodies and basically kind of in proteins, but also for RNA cell basically therapies and so much more. And these bio-AI models are going to improve speed and probability of success in places far beyond just the early discovery space, from process dev to basic kind of clinical trials to kind of so much more. But when we spend time with the actual dry lab teams, we hear how much their effort goes into solving these foundational problems before they can even get to true AI and ML. The molecule and assay data that they need from the actual dry lab oftentimes isn't structured or standardized enough to actually train those basic kind of models. Even when it is actually basic kind of structured, they're bogged down by the effort that it takes to query, aggregate, and just kind of get that data ready for actual model basically training. And they're also spending so much time just rebuilding and rerunning the same computational pipelines that they barely have time to get to actual AI and ML. These are really table stakes problems for which good off-the-shelf software just isn't out there right now. And our goal is to really help dry lab teams offload so much of that work so they can focus on truly novel science. So let's now walk through 3 big investments that we're making in powering the dry lab. The first is really in enriching how we model the molecule itself. Using AI in the discovery space is really predicated on being able to connect molecule to assay data in a way that machines can understand and actually train on. Earlier, Nick showed how we're helping with the assay data side of this actual problem, but the first half of this problem, modeling the actual molecule itself, is also getting much, much harder because of this kind of explosion in complex molecule formats. Oligotherapeutics, for example, are this really kind of amazing molecule type that are really rich for the application of AI, but they're really complex to actually model in the right way. This past year, we kind of built out much richer support for oligo-based kind of conjugates, including chemically modified residues and also based kind of conjugated small, basically kind of molecules. Deeper access to the molecule structure itself has been a key piece of helping dry labs that many of our basic kind of customers access higher quality data to build AI models for oligo design. This coming year, we're going to also deepen our support for complex antibodies and proteins. AI models for predicting properties, or even for engineering the antibodies themselves, have taken a massive step forward. But with so many complex antibody formats that our customers are now working on, customers need richer tools for modeling multispecifics and ADCs. Now, the flexibility of the Benchling registry has made it a tool of choice for antibody companies for years now. But to best use this data for AI, we have to have more of an out-of-the-box point of view on how these complex formats should actually be modeled. This more built-in data model will make each sequence component and its lineage easier to actually query, which will then simplify running computational workloads on top. So our second investment is in simplifying how dry labs can actually access wet lab data to train their models and see how well they're working in real life. Much of this directly ties to what is Remus talked about earlier around an open platform, in particular, how easy to access that data truly is. Right now, the BCM Dry Lab uses our rich APIs for accessing wet lab data and getting that data into places where they're actually building models, whether that's Jupyter notebooks or kind of larger scale data science platforms. Then, after building those models, Dry Labs can also use our APIs for uploading model predictions back into Benchling itself. This is a really powerful step because it creates this central source of truth for experimental and predicted data that can then drive critical choices about which models are actually working the best, but also about which actual candidates to move forward. But we basically really want to go a step further. The hardest part about getting data ready for the dry lab is not just accessing data, but understanding the wet lab process and data model enough to know what data to query in the first place. This is fundamentally really a translation problem between the wet lab and the basic dry lab, and it makes it a great fit for LLMs. So let's take a quick look at how experimental and predicted data can be stored and queried within the Benchling product. So I have an antibody pulled up here that I registered, and I can see basic information on it, like the chains that compose it or the basic molecular weight. But I can also see some predictions I've uploaded as well, like the predicted percent monomer, which is one way to predict how much the protein might actually aggregate. I can dive deeper by going into the results tab. Here I can see experimental results from the actual wet lab, like an SEC assay, which is a way to basically kind of experimentally assay the same thing. I can also see that prediction uploaded by the basically dry lab, along with more data about the model and the model version that was run. So let's say I'm a scientist who wants to compare the experimental and predicted values in basically kind of aggregate. Right now, this is often done through basically kind of spreadsheets, asking the wet lab to export assay data, manually joining it to the predictions that you have, which not just wastes time, but loses a lot of the actual context. So using Benchling Insights, you can write a query that pulls all this data in one place. But how do you know where to look? Maybe you've poked around and found some of the kind of tables, but figuring out exactly how that data was captured can take a lot of time. So that's where this new SQL assistant that we're building comes in. You can just type in pure natural language what you want to actually query, join, or basically kind of filter. So behind the scenes, the LLM has all of the context around your actual data model, your field names, your field basically descriptions, links, and so forth. And it uses all of that context to craft the right query for you. So how much time could that save? So from there, you can basically run this kind of query. It'll pull together that experimental and predicted data in one place. And then you can even use the tools Nick showed earlier to create kind of charts and basically graphs to take a deeper look. So so much of the problem in the dry lab is getting the actual data that you need. We're currently testing this out with a few customers right now, and we're finding out that our platform, plus kind of the power of LLMs on top, can be a huge step forward. So our final investment is really offering more complex data kind of analysis tools and even predictive models out of the box to help dry labs offload more of that work that can actually be easily kind of standardized. Those basic kind of analysis pipelines Nick showed earlier already create kind of this no-code option for some of the data processing that basically kind of dry labs have to custom build for the wet lab right now. But let's take an even more complex use case. As the discovery process has become higher and higher throughput, biologics teams really need software that can help them analyze sequence data and select the right candidates at higher scale. NGS has become a very common technique, and that really basically kind of acquires software that can perform a wide range of sequence kind of assembly in basically enrichment and kind of other workflows. Selecting the right hits then also requires overlaying assay data on top and finding key sequence features like live abilities. Now, all of this typically falls on computational teams to custom build for themselves. And that made sense while these techniques were new. But at this point, the bioinformatics can really be standardized on some best kind of practices. So, for the last few years, we've been following this startup called Pipe Bio that is solving this problem by building out-of-the-box bioinformatics tools that have become a linchpin in the antibody discovery stack of many large pharma and cutting-edge, basically kind of biotechs. I'm really excited to let all of you know that we are in the process of basically kind of acquiring Pipe Bio, and they'll be fully joining the Benchling team. Pipe Bio helps scientists analyze sequence data and select better hits while really taking off that burden of custom building bioinformatics pipelines. Let's take a bit of a kind of deeper look at why we're so pumped about their actual product. So since their founding in kind of 2020, Pipe Bio has built a wide range of sequence analysis and data viz capabilities in a really modern cloud-based way, giving biologics teams this purpose-built UI backed by fully scalable compute. They're really focused on the logic space and support a wide range of different molecule types, from highly engineered antibody formats to TCRs to even peptides. The heart of PipeBio is this web interface for viewing sequence-based analysis and assay results that's been engineered for high scale. Documents of sequences can scale to thousands of Sanger reads and even millions of NGS sequences to support higher throughput work. The power of PipeBio, though, comes also from these powerful out-of-the-box workflows that are purpose-built for the biologics discovery space. These workflows can then be tweaked to your specific use cases without writing any code, and remove the need for you to monitor and operate your own pipelines. What's really cool is that the outputs of these workflows can then be basically kind of visualized in really a wide range of kind of no-code tools. You can easily see a range of sequence features in just a few clicks. You can overlay functional assay data on top. And all of this viz, including complex ones like, for example, kind of clustering, really kind of simplify the process of selecting better hits, while also kind of making the source of truth for critical choices that are made and some of the kind of data be basically behind them. So, we're really excited about PipeBio, not just because of the bioinformatics that they offer, but also because of their vision for democratizing access to AI and ML techniques for antibody design. We really believe that AI and ML to, for example, predict the developability of this kind of antibodies will become the de facto way that antibodies are actually made. So, we're just really excited about the impact PipeBio will have on the biologics discovery space. The founders of PipeBio, Yannick and Owen, are here with us right now. Please head over to the bioresearch kind of demo booth to chat with them and actually learn more. And you can also sign up for basically kind of a free trial on their website. So from scaling the wet lab to powering the actual dry lab to building the kind of platform that really underpins it all, we really believe that this tectonic shift happening across the software landscape right now will help us move at the speed that the science has been moving for kind of years now. We're really just so fortunate to have had all of you as kind of partners over the course of the last kind of basically kind of decade plus in building out that actual product kind of a vision. It really is the start of a whole new kind of generation of the actual software, and I'm really pumped to see how all of you will actually use it to transform how science is actually done. So we'll be talking a lot more about each of these topics as the day goes on, but for now I'll hand things back to kind of Saji about to basically kind of share more about what's to come. Thank you.
All right. Big thanks to Ashu, Nick, Remus, Shauna for sharing all those updates. The one piece of feedback we always get after Benchtalk is that you want to see more product. So what was that? 4, 5 demos? I don't think we could have fit any more in here, but I'm sure some of you will ask. So thank you so much for being here. It's going to be an amazing 2 days. Here's what you can look forward to next. 1, meet people, make some friends, hear about their Benchling stories. Don't just hear it from me. 2, learn more about the product and what we've been shipping in the workshops tomorrow. I think they're all sold out, so hopefully you got a spot. And then make the most of the Benchling team that's here today. Go to the support lounge, give them your questions. We have lots of product managers around. Grab them, go deep on our vision with them. So thank you again, everyone, and I hope you have an awesome 2 days with us.